everyone. I'm Princess Leidopik, and right now we have here a rock cycle, no? So, rock cycle, no, today we're diving into a fascinating world of rocks. Yes, this one is the rock cycle. That it has a never-ending story of how rock change, how rock evolves, and born and reborn again. So this cycle, no, it shows us that the earth is constantly alive, no, beneath our feet. So right now, right now we're going to know what is the process on how a molten rock forms a how a molten rocks forms. So through the this volcano, as you can see, there is a lava and a magma. So volcanoes, did you know that volcanoes, it is a doorway that lets the magma become a lava. So this process of magma and lava, no, this process of magma and lava, it involves a transformation, no, from the magma and to the lava. So beneath the Earth's surface into a lava, no, of course, these transformations occurs through a volcanic eruptions. When the volcano erupt, no, there's a magma here, and when the volcano will erupt, then here it comes that the lava will going to the Earth's surface. And the key differences between the magma and lava is that they lie in their location and behavior. That the magma, it becomes underground where the heat pressure, no, where we can find the heat pressure. Well, the lava, this one, is that it released upon reaching the surface, where it cools quickly and form new landforms. So that this rock cycle, no, in this rock cycle is that it is a fundamental of the Earth's geological processes and shape the planet's landscape.
So, my name is Chrislyn Dianga. So, this is the continuation of a rock cycle. So, in the rock cycle, crystallization of the magma. So, crystallization is the birth of the rock. It is a specific stage where the liquid turns into solid. So, we have the two paths of crystallization. So, the most important rule in the crystallization is the speed of cooling determining the size of the crystals. So first, we have the slow cooling. So this slow cooling is a deep underground where the magma trapped deep inside the earth. So it surrounded the warm rocks that act like a thick blanket. It is take thousands of years to cool down. So this result of the minerals have long time to grow into large or visible crystals. So this type of rock, this type of igneous rock is intrusive rock, so or platonic. So the second one is the fast cooling. So this is happening or occurred in the surface. So when the volcano erupts, magma becomes lava. This one. So it hits the cool air or ocean water and hardens almost instantly, even in the seconds or in a day. So the result of its mineral don't have time to grow. So they form a tiny microscopic crystals. So or no crystal at all. So this type of igneous rock is extrusive rock. So this one and this deep underground is the igneous rock. It's called the intrusive rock and extrusive rock.
Okay. Again, good day, sir. I am Crystal Fuentes, and I will be discussing the process of igneous rock. So again, first, igneous rock are the Earth foundation. So it is born from the cooling of molten rock, whether they freeze deep underground or erupt from the volcano. So their identity is defined by one thing. It is the heat loss. So you can identify them by their texture. First, the extrusive rock. So like a granite, it cools slowly underground, growing large under lucky crystals. Also, you can see with the naked eye. So second is the extrusive rock. So like a basalt or the obsidian, it cools rapidly on the surface. So this result is a tiny crystals or a smooth glassy and finish. So because they form from a liquid melt, they contain no fossil and no layer, just a solid. So it is durable mineral structure. So now we will now I will be supposed to be and now I will be discuss the slow uplift of the surface. So the uplift surface, how can Durock form miles deep reach from the surface? So it is a form of tag team effort. First is the tectonic uplift. It is the massive collision of earth plates squeeze the crust and pushes these deep rock bodies upward. Second is the erosion. It takes over a million of years. Wind, rains, and glaciers stripe away the miles overburdened. Now the second is the erosion. So erosion takes over a million of years, over a million of years. Wind, rains, and glaciers stripe away the miles overburdened. So the soil and the softer rock setting on the top. So that's it. So as the weight is removed from the crust, actually the height is higher. So finally exposing the raw igneous core to the sky from a liquid furnace to the mountain peak. That is the process of the igneous rock.
So, good day everyone. I am Judy Claire L. Velasquez, and today I'm going to discuss the weathering and erosions of the rock cycle. So, have you ever wondered what is weathering and erosion? So, let's define what is weathering. So, weathering is the natural process of breaking down rocks into smaller pieces over time, by which atmospheric and environmental agents such as the wind, rain, temperature changes, so these integrate and decompose rocks. So it can be categorized into two main types: the physical weathering and the biogeochemical weathering. So when we say physical weathering, this involves a disintegrations of rocks into smaller fragments without changing their chemical compositions. So let's proceed to the biogeochemical weathering. So when we say chemical weathering, this involves the decompositions of rocks through chemical reactions and altering their minerals compositions. So next, let's proceed to the erosions. So what is erosions? So when we say erosion, it is the process by which weathered rock and soil particles are transported from one location to another locations. The primary agents of erosions are the wind, rain, ice, and gravity. So let's define what is the primary agents wind. So when we say wind, imagine the wind carrying tiny sand grains. When these grains hit a rocks, like a constant, gentle sandpaper slowly grinding away, so a bit of rocks, over time, this can wear down even to the very hard na mga rocks. So, the next is the rain. So, as we all know that rain can be slightly acidic, so it can, and over time, this acidity can slowly dissolve ng mga minerals na present at mga rocks. So next is the ice. So glaciers is a powerful force as it moves and scrapes and drags rocks along with them. And lastly is the gravity. So gravity is directly transport material downslope. So for example, the landslide or the rock falls. So if these four forces work together over long periods of time, it constantly reshapes our planet's surface. So breaking down mountains into sediments that can be moved to a new locations.
What is transports and deposition, and how rock fragments travel and settle into layers or sedimentations? So transports is the movement of weathered rock fragments or sediments from one place to another. After rocks are broken down by weathering, the small pieces don't just stay there. They are carried away by natural agents like water, rivers, rain, oceans wave, or in wind, ice, glaciers, for gravity, landslide, and for example, a river can carry a sand, silt, and small stones downstreams for many kilometers. So deposition happens when the transporting agent like water, wind, ice, or gravity loses energy and can no longer carry the sediments. So when that happens, the sediments slow down, drop, settle in a new place. This usually occurs in areas like river mouths or deltas, lake bottoms, ocean floors, deserts, or how rocks fragments travel and settle in layers. So sedimentations, this whole process is called sedimentation. So here's how it works step by step. First is the withering breaks down into smaller pieces, and second, transformation moves those pieces. And when movement slows, deposition occurs. So over time, sediments build up in layers. So heavier and larger particles settle first into small, lighter particles, and that's why sedimentary rocks form visible layers. Each layers different time of depositions. So transport is the movement of weathered rocks fragments by water, wind, ice, or gravity. Deposition is the process where the sediments settle down when movement slows, forming layers through sedimentation over time. Let's continue the process of rock cycle. These are the compaction and cementation. So, compaction and cementation are the two main processes that turn loose sediments into solid sedimentary rocks. First is the compactions. So compaction happens when the layer of sediments like sand, mud, small rock fragments pile up over time. So as more layers accumulate on the top, the weight increases and the pressure pushes down on the lower layers. Because of this pressure, the sediments are squeezed together and air and water spaces between particles are reduced. The particles move closer and become tightly packed. So think of it like a pressing down on a sponge. It becomes thinner and tighter. For cementations, after compactions, minerals dissolved in groundwater move through the tiny spaces between sediments. So the common minerals of cementation we have is the calcite, silica, and iron oxide. So these minerals fill the remaining spaces, harden over time, and act like natural glue. And this glue binds the particles together. So how pressure turns loose sediments into solid rock. Here's the step-by-step formation. These are the step-to-step formations. We have the rock breaks down through withering and erosion, forming sediments, and sediments are deposited in layers. So over time, more layers build up. So the weight creates pressures or compactions. The minerals cement the particles together, and the loose sediments become solid sedimentary rock without pressures. So sediments would stay loose like sand. With pressure plus mineral cements, and they become rocks. So compaction squeezes sediments together due to pressure from overlying layers when cementation binds them using dissolved minerals. Together, these processes form solid sedimentary rocks.
We already know how the rocks turn into sedimentary rocks. And now I am Regine S. Ramiro and will tackle about metamorphism. So we begin with the geothermal gradient. As a rock is forced into the crust, either through subduction or massive sedimentary loading, it enters a zone of increasing thermal energy. Science dictates that for every kilometer of descent, the temperature climbs roughly 25 degrees Celsius. This isn't just heat, it is the kinetic energy required to stabilize atomic bonds. The rock remains solid, but its internal chemistry becomes fluid in potential. Then, the pressure takes hold. First, due to static pressure, the weight of miles of overlying crust squeezes the rock from all sides, forcing its volume to decrease and its density to spike. But the true architect of change is differential stress. When tectonic plates collide, they apply a ruthless one-directional shoe. Under this squeeze, minerals do not just sit there. They rotate. They align themselves perpendicular to the stress, creating the structural fabric we call foliation. Now look at the lattice level, kaning mga puti-puti. This is the smallest, most essential detail. This is the solid-state diffusion atoms or ions that gain enough energy to break away from their original mineral structures. They migrate through the solid mass, seeking new partners. A humble clay mineral, unstable at these steps, breaks apart. Its ion travel and regroup to form garnet or mica, minerals that are thermodynamically stable under this extreme condition. The rock is literally eating itself to grow something stronger. Every metamorphic rock is a survivor of a specific PT path, or pressure temperature path. If the pressure is high but the temperature is low, we get blue schist. If both are extreme, we get gneiss, where minerals have separated into distinct dark and light bands. This is the ultimate objective truth of the Earth. Under enough stress, even the hardest stone must reinvent itself or be crushed. The process ends when the rock exhumed back to the surface. Rena, frozen in its new identity. It is a chemical record of a journey to the depth, a witness to the fact that internal change is the only way to endure the weight of the world.
So, good day everyone. I am Bernadette Trusty Sereno, and today I'm going to discuss melting in the rock cycle. So, what is melting? So, melting, it is the process that transforms solid rock into molten rock known as magma. So, when rocks are pushed deep into the earth through plate tectonics or subduction, they encounter high temperature and pressure that cause them to melt, becoming a magma. So the resulting magma is less dense than the surrounding solid rock, causing it to rise. As it moves upward and cools, it solidifies, forming new igneous rocks. So these newly formed igneous rocks are then subject to weathering, erosion, and other processes continuing the rock cycle.